Today we will go to discuss about problems based and solved on heat transfer conduction. And before going to that problem, we know about what is the heat transfer and what are the modes will be occupied in that heat transfer. Heat transfer means it's a heat transfer from one medium to another medium. That will be the higher region into the lower region. That will be the three modes it will be occupying the transfer is the conduction, convection and radiation. So conduction means its heat transfer is from solid surface to the low medium solid surface. So in this problem it based on the rate of heat transfer in the vertical walls. So the first we have to occupy it as the given data are is this is given is a composite wall, and this dimension it will be having the size of 4 meter by 3 meter and by 3 meter high. So the length is equal to 4 meter and breadth is equal to 3 meter and also height is equal to 3 meter. So from this given data and from this size we need to find about the area is equal to length into breadth is equal to 12 meters square. And another areas of the individual section is L1 is equal to 25 centimeter. We need to convert it into a meter is 0.25 meter, and the thermal conductivity K1 is equal to 0.4 watt per meter Kelvin, and another section of L2 is equal to 0.02 meter and K2 is equal to 54 watt per meter Kelvin, and the final section of L3 is equal to 0.8 meter and thermal conductivity of the third section is equal to 0.2 watt per meter Kelvin. So the temperature level in inner surface and outer surface is indicated as 600 degrees Celsius and T2 is indicated as 60 degree Celsius. So here it is assumed it is a 3 layer. So the 3 layer of is coating is this is first layer and this one is second layer and this one is third layer. Here the temperature is indicated as T1 and outer temperature is T3, and this is a thermal conductivity K1, K2 and K3. So here we need to find about the heat transfer Q is equal to what. So next we go to the solution part. So once again I will summarize of the given data is here this is a 3 based structure problem is here, and the temperatures and T1, T2 are given, and the areas length, breadth, height also given, and the thermal conductivities K1, K2 and K3 are is given. So from in this problem we need to find about the what is the net heat transfer rate in this problem is occupied is here. So the thermal conductivity is it is the ability of a substance to conduct heat in that particular material. So the unit of the thermal conductivity is watt per meter Kelvin. And we know that the solution part, first we have know to about the Q heat transfer is equal to del T by R. So here the Q is then a heat transfer and del T is the temperature gradient and R is the resistance of the sun. So here in this next we will go to and discuss about del T mean difference between the temperature difference between the inner and outer temperature, and R is the resistance of the particular area and resistance it will be having the L by Ka.